So today looking at permutations with restrictions, permutation with a like object. What does it mean, like objects? That, for example, we have in our set of objects, some are identical. So when we swap them, nothing changes. For example, we have 4 blue marbles and 3 red marbles. In how many ways we can arrange them? Because blue marbles are all identical and all red marbles are identical. So when we swap 2 red marbles or 2 blue marbles, it will be the same arrangement. So in this case, how we calculate the number of arrangements? We have total possible number of arrangements. We have 7 objects, so we will have 7 factorials, and we need to divide by, we have 4, and so general formula is n squared, n factorials, where n is total number of objects, divided by n1 factorials, n2 factorials, where n1 is number of the one type of the identical objects, and 2 is number of another identical objects. If there will be more groups, then we will be times n3 factorials, n4 factorials, and so on. Because swapping places in each group doesn't change anything. So in this case, it will be 7 factorials divided by 4 factorials, 3 factorials, 7 factorials over 4 factorials. We'll have 1, 2, 3, 4 cancels out. So we have 5 times 6 times 7 left on the 1 times 2 times 3. So it will be 35 ways. It will be 35 ways how we can arrange 4 blue and 3 red marbles in a row. Make sense? Another example, say from your booklet. Question question example 3 on page example 3 on the page 11. In how determine how many different permutations or arrangements can be made from the word abracadabra. So we have like objects, same letters. So when we swap any A's, nothing changes. So how many A's we have?
5.
We have 5. Now we also have repeated B. We have 1, 2. We have repeated R. We have 2. And C not repeated, D not repeated. So all together we have 11 letters. So total number of the arrangements is 11 factorials, which we need to divide by 5 factorials, 2 factorials, and another 2 factorials, because they are repeated. So we will have 1 times 2 times 3 times 4 times 5 cancels out. So we will have 6 times 7 times 8 times 9 times 10 times 11 divided by 4, which will be equal 83,160. So we always dividing by number of factors how many like objects we have, which if we swap them, does not make a new arrangement. Make sense? Now let's consider the example 5. I think on the next page probably. Yeah, example 5, page 12. The student council needs to fill the positions of president, secretary, and treasurer. And there are 6 candidates. There are altogether 6 candidates. Each candidate can fill only one position. Determine in how many ways it can be done if there are no restrictions. If there is no restrictions, so no restrictions, in how many ways it can be done? That will be permutation of 3 objects out of 6, which will be 6 factorials divided by 6 minus 3 factorials, so 4 times 5 times 6 divided by 2 times 3 equal 20, no, 6 factorial divided by 6, we have 4 times 5 times 6, sorry, that's already, it's 4 times 5 times 6 equal 120 ways. So if there is no restrictions, any person can be anybody, except that one person cannot take 2 positions, you'll have 120 ways. B, 10 must be secretary. So if one person already chosen for one position, what this problem changed to? What it becomes?
5 and 2.
Yeah, we're now choosing 2 out of 5. So we have permutations of 2 out of 5. So 5 factorials divided by 5 minus 2 factorials. 5 factorials divided by 3 factorials will be equals 20. Another restriction, if 10 must have one of the 3 positions, which we will need to use here to solve the problem. Is 10 must have one position.
Use each scenario where it's in each position.
Yes,
So it's like 3 times that.
Yes, that could be called addition principle. Because we consider that number of ways, there can be 10 can be president, 10 can be secretary, 10 can be treasurer, and we add them, so 20 plus 20 plus 20 will be 3 times 20, will be 60 ways. Make sense? And the last one, 10 is not in any of the positions. What it will become if 10...
6 choose 2, 5 choose 3.
2. Sorry, it becomes 5 choose 3. So we're choosing 3 out of 5. So permutation of 3 out of 5. And 5 factorials divided by 5 minus 3 factorials, which will be equal 3 times 4 times 5 will be equal 60. Make sense? That's how we deal with the permutations, with the like objects, or with the restrictions. That's all new for today. Like, subscribe, and donate to help fight terrorist countries and organizations, Russia, Hezbollah, Iran, Hamas, etc. Support Ukraine and Israel.